which gives definite holes to this sequence to account for the generation. Einstein knew that because sense perceptions cannot give you reality, reality lies in the imagination. By striving to comprehend the universal as Einstein did, you get a sense of the reason or beauty of certain things. A type of resonance occurs between the principles ordering the universe and the innate ability of your mind. As a starting point, we will look at the theory of special relativity in this first chapter to get a glimpse at the method of insight Einstein had on life and science. The realm of science was in major flux during Einstein's youth. The discovery of radioactivity and other new phenomena made for an open environment. Röntgen's X-rays in 1895, Becquerel and the Curies on radiation in the 1890s, J.J. Thomson with the discovery of electrons in 1897, Pasteur earlier with work opening the field of microbiology to Gurvitch, Mendeleev's creation of the periodic table leading to breakthroughs in physical chemistry and medicine, Hertz's measurement of the speed of an electromagnetic wave being that of the constant speed of light, Max Planck, with his investigation of heat radiation at the turn of the century, had put physics in a crisis. After nearly 200 years, Newton's mechanics, which was to suppress the real history of the science of motion of Leibniz, was clashing with another cover-up job by Maxwell and others of the true development of the electromagnetic field theory of Gauss, Weber, and Riemann. Newton's scheme of motion, based on instantaneous action at a distance through empty space, by a force primarily determined by a mass, by its nature did not fit with Maxwell's equations of electromagnetism. Maxwell's equations operated on the foundation that the combined action of electricity and magnetism propagated in a wave motion at the speed of light, through an immaterial medium, an energy field, without mass. If only they could keep their lies straight, a stupefied population wouldn't have known the difference, since the explanation of physics derived from these theories so well match up with our everyday experiences. There seems to be empty space between objects of mass. Our eyes don't see anything in between. When we bounce a ball, it seems to have an immediate reaction. And who could argue with Maxwell, since he is describing something which we cannot see? To start with, the theory of relativity is not something that was original to Einstein. Einstein was not the first person to use this term. The idea of something being relative or relational or comparative, this has a long history. For example, you have something called the relativity of motion, where according to one person, they can consider themselves stationary, and another person in motion, where the opposite could be viewed from the person who is thought to be in motion. They can think that you are actually moving and they are stationary. Simple relativity of motion. I should prepare a video for you guys to see this idea. So here we have some friends. Here's Leona. In relation to us, she's moving. So from our perspective, Leona is moving to the left. But from her perspective, it's all of us, or in this case, the cameraman, who's moving while she's stationary. Her body's not moving. So who's right in this case?
Leona.
Who's actually in motion? Both of them would be able to argue that they are stationary and the other one is in motion. And this is a simple idea of the relativity of motion. Who's stationary and who's in uniform motion. A consequence of this is that the laws of motion the laws of mechanics are true no matter if you're stationary or if you're in uniform motion. Meaning that there's no experiment in mechanics, in the laws of mechanics, that will indicate to you that you're in motion, that you're in uniform motion. So try as you might come up with any experiment you can think of using mechanics, you're not going to be able to indicate or prove to yourself that you are the one who's actually in motion. What this means is that all laws of mechanics are going to be true, are going to be viewed the same way, no matter your reference frame, whether you're stationary or in uniform motion. So it seems that the laws of mechanics don't have a preference to how they're viewed. The laws of mechanics don't make it necessary that you have to be in a particular reference frame to view them. There's no ultimate reference frame from which they have to be viewed. There's no ultimate rest nor ultimate motion. For example, again, this is Leona looking at Newton's cradle while standing still. So all the laws of mechanics involved in Newton's cradle, inertia, action, reaction, mass, force, height, turning into velocity, are all being observed. Now, when she steps onto a moving walkway and uses the Newton cradle, she again observes the same laws. So she's not able to tell, using this mechanical device, whether or not she's in motion. We'll see those two instances together. One stationary, one in motion. In both cases, the law of mechanics are viewed the same. So from the standpoint of mechanics, there's no preferred reference frame. There's no ultimate box that they are measuring themselves against. There's no origin, some point in the universe from which they gauge themselves. But instead, they are viewed the same way from